Friends, am I audible over there? Am I audible, friends?
Yes, sir.
Okay. So yesterday due to some interruption, we stopped our discussion up to the crystals. So this is like a second topic, states of matter and properties of matter. In that crystals we were discussing. So straight we'll go towards that part. Yeah, so this is what the crystals are, basically liquid crystals, what we were discussing. So as I told you, crystals are a part of solid substances. Rather, this is the phase in which, or it is lying in between solid and liquid. So it is the fourth state of matter, which is known as liquid crystal or mesophase stage. So it's not always like crystals should be like solid only. Okay, and some crystals will be beyond solid. It will be in the range of solid and liquid, so that's why it is known as a mesophasic form. Or apart from solid, liquid and gas, it is one more form, we can say mesophase form or mesomorphic form. So this is the thing which is like seldomly occurs in between solid and liquid, and it possesses characteristic of both liquid and crystalline solid. So whenever we are talking about crystals, it's not like always a solids. So some liquid substances also may exhibit in crystalline form. So as I told you example, like phenol will be lying in crystal forms. So that is also the one thing. And even a number of substances we can bring it out in a crystalline form. So like salt and all, salt is not always will be in crystalline form, but we can bring it out in crystalline form. In crystalline solid state, the molecules are held in a position by intermolecular force. So of course, compared to liquid, the intermolecular forces will be strong in case of crystals, because in liquid it will be weakened, but in case of liquid crystals, since it is a in between solid and liquid, so it will be the center part, or what we can say, the intermolecular force also would be strong as far as liquid phase concern. The particles in a solid move but cannot cross each other because the attracting of number of atoms or molecule are too strong to overcome. So that is what they are saying. The particles in case of gas, how the particles will be, the particles will be getting diverted or will be in diversified motion. So it is not the case in case of a liquid crystal. Rather, it is like it will be in a definite shape, or it will be moved in a particular shape only. So it will, its movement, or rather moment, will be regulated or limited. So this is what the thing about liquid crystal. In the liquid state, the molecule move to random positions. So that is what in liquid compared to solid and crystal, it will be moving freely in case of liquid, and that won't happen in this liquid crystal. So the increase the molecular motion overcomes the weaker force, but the molecule remain bound by stronger forces. This produces a molecular arrangement where the molecule is layered, but within each layer, the molecules are arranged in a random position. So this is the borderline, we can say, for a liquid and solid. So the molecule can slide one around the other, and a layer can slide over one another. So because of a kind of geometry is getting formed, and that geometrical shape only we are calling it as a liquid crystals or crystalline substances. The molecular mobility generate fluidity in a liquid crystal set. So that is what the actual mobility of a molecule will generate fluidity in liquid crystal state. So whenever you will feel to write the examples of liquid crystal, you will be thinking about different crystal forms, like phenol I told you example, which is liquid crystal. Even your routine like salts, sodium chloride, ammonium chloride and all, they will be having a specific shape, isn't it? So those also can be categorized as a crystal, but those are not liquid crystal, rather those are only crystals, or we can say solid crystals. So you can see the different geometry, crystalline, solid phase, how the arrangement of those crystals will be exhibiting in case of solid phase, or we can say solid crystals. Rather a liquid crystals arrangement you can see here, it's like it's not having proper shape, rather it is dispersed. Have you understood? You can see the dispersed phase. In that also they have compared the liquid amorphous phase and liquid crystal phase. So crystal, when we are talking the amorphous form, it's like soft powder and all we can say, but those also will be defined in a particular size and shape. Though those are not categorized as the crystals, but rather we can say it is a, like some specific size, or geometrically it will be identical in particular space. So that's why the arrangement of those amorphous type of substances they have shown here, and the crystal substances they have shown with a specific geometry. So this is what about the liquid crystals and solid crystals and their arrangement. Later, if we will see the type of liquid crystals, you can see if thermotropic liquid crystals, which is ultimately whenever the term thermal will come, so temperature dependent. So thermotropic in the sense temperature dependent. So these are the liquid crystals which are said to be thermotropic if liquid crystalline properties depend on temperature. So there will be categorized these thermotropic liquid crystals in three part. That is one nematic liquid crystals, second one is smectic liquid crystals, and third one is cholestric liquid crystals. So of course these liquid crystals which are thermotropic in nature or thermotropic liquid crystals, those are absolutely dependent on temperature, or we can say more specifically the crystal form which it appears, it is with a specific or it will be with the temperature, or it is responding towards the temperature. Then if we'll go in detail, nematic liquid crystals, it's like the molecules have no positional order, but they have long range orientational order. So here any kind of a position is not defined for those nematic liquid crystal, rather the actual orientation will be having in a long order, or what we can say the arrangement will be in long manner, though it is not having any position, it is not having any shape, but the arrangement will be it like longer. How we can say, like what we can say, the arrangement of jewels and all, how it will be. So likewise the arrangement you can see here, first diagram of nematic type of crystals. Then second one is smectic. So smectic, if you will see this kind of or in this kind of crystals, the molecules have been arranged in a specific position. Have you understood? They will be lying with specific position and with specific orientation also. So one direction you can say like unidirectionally it is arranged. You can see the difference between nematic and smectic. So nematic, if you will see, though it is arranged in unidirectional, it's like some kind of wide space you are able to see in between nematic crystals, or the position of molecule. If you will see, the wide volume or wide space is we can identify, but it is not the case in smectic. You can't identify that much wide space available or free space available in between molecules of those crystals. So this is about the nematic and smectic type of crystals. Third one is cholestric. If you will see the cholestric crystals, this cholestric type of phase can be defined as special type of nematic liquid crystal. So of course there will not be having any position. So since it is a part of nematic type of liquid crystal, it will be not having specific type of arrangement in which thin layer of parallel mesogens have their longitudinal axis rotated in adjacent layer at certain angle. So you can see here it's not unidirectional. If you will see the nematic and smectic, it is running in one direction. So they have shown the arrow also, but it is not the case in case of cholesterol. It's not unidirectional, or rather you can say it is a multi-directional. Have you understood? So you can see the arrow position. In that arrow position, they have shown the rotation in any manner, or it will be in free manner. Okay, have you understood? So this is about the cholesteric liquid crystal. So these are the three type of liquid crystal, we can say, which are temperature dependent, categorized as a thermotropic liquid crystals. Then if you will see the lyotropic liquid crystals, so these type of crystals are not based or responding to the temperature, and these are prepared by mixing two or more substances, of which one is polar and another is lyotropic liquid crystal. Example, soap in specific substances. So those lyotropic crystals, if you will see, like a columnar, then a rectangular, hexagonal. So this kind of arrangement you can see in between the substances whenever you are adding some kind of soap or a detergent substance with active ingredient or any pharmaceutical ingredient. So the arrangement of crystal will be in a like diversified manner or lyotropic manner. We can say the columnar, rectangular, hexagonal, such kind of a shape will be there, or appearance will be there. So thermotropic and lyotropic, you can identify the crystal. First one is based on temperature, and second one is upon addition of two or more substances. In that also, specifically, if we are adding the detergents or soap, specific crystals will be getting formed. Third one is, or next one is a glossy state. This is a one more phase. So solid, liquid, gas, then crystals we have seen. Then one more phase is there of the substance or matter. One is glossy state. So glossy state means what? So glossy state of material refers to non-equilibrium solid state, such as in typical inorganic glasses, synthetic non-crystalline polymers, and food components. So this thing can be observed in case of inorganic glasses, synthetic type of non-crystalline polymers, and food components. So this is something like polythene. If we will see the polythene, how the arrangement of polythene is there, it's like it, that kind of example, that polythene we can't say as a solid also, and it is not a liquid also, it is not a gas also. So it is a one kind of polymer. The polythene is a one kind of polymer, isn't it? And that appearance is known as a glossy state. So characteristic of glossy state includes transparency, solid appearance, and brittleness. Brittleness in the sense, it can be teared, but it will not be, it is not breakable, but it can get a tear. So that is the brittleness. In such a system, molecule have no ordered structure, and the volume of system which is larger than that of crystalline system with the same composition. So here they have given some example also: glass, rubber, leather, such things. Even syrup also they have given example as a pharmaceutical example. And even plastic also, you can say plastic in that, not all type of plastic, plastic paper, the plastic paper or polythene paper, more specifically, if you will see, those substances are known as glossy state. So since glass example, why they have given is glass is a solid substances, but since it is inorganic one, so it is made up of from silicon and all, so they have given example of glass. Apart from that, rubber, because rubber, you see, it is having some brittleness, and it is one stress or tense we can give. So because of that, it will get elongate, but it will not get tear. Have you understood? So those kind of substances with some kind of magical appearance or glossy appearance are known as substance with glossy states. Glasses are generally formed by melting crystalline material at very high temperature. So this is the one thing about the glasses, which they are formed from silicon. So generally, if we will see the glass is made up of silicon material. So by melting that crystalline silicon, and even since it is inorganic one, we can form the specific glass which is appearing as a glossy state. And even when we are melting that thing, it cools and the atom enclosed in a random state before they can form a specific crystalline arrangement. So it is like one kind of process of glass how they are making. You no need to go more detail in those things and all. Just you understand glossy appearance. That glossy appearance is as I told you, this is like non-equilibrium. It is a one kind of solid state only, but it is not a solid state. It is a type of solid state, but it is not actually solid state. And basically it is a inorganic type of compound utilized, or it is appeared in the glossy state. And example you can say these polymers, I mean polythene paper, glass, rubber and all, there's a glossy appearance. And even they have divided based on its characters and all. One is the first type, second type and third type. So it's not like a routine material which is used in pharmaceutical. This is also very rarely we can use, or mostly the containers and all, pharmaceutical containers and all using purpose, they are using this different glossy state substances. So crystalline and amorphous solid. Now, when we were describing crystalline and amorphous solid, earlier only we studied crystals and amorphous type of substances. So these substances like crystal and amorphous are different excipients or additives which are used in pharmaceutical formulation. It would be like a crystals and amorphous type of solid substances. So number of metallic, ionic, valence and molecular bonds are involved in these kind of solids. So metallic nature, it will be having some metal nature. It is a responding to magnet and all. Ionic nature, which is responsible for ionic type of bonding, like positive and negative interaction. And then valence bond. So valence bond is like the X shell electron which is present, which is producing the valence bond theory. And molecular bond, so different molecules which will be combined to form a bond. That kind of interaction will occur in this solid. So these are the particular thing we need to remember in case of crystalline and amorphous type of substances. Then arrangement, which is as I told you, it is a regular repeatable pattern which is happening in case of crystals of this solid phase. And the units can be atoms, ions, molecule, which will be having interaction like covalent, electrostatic interaction. So so this actual the theory involved in crystalline appearance of substances, it is blamed to covalent theory, electrostatic theory and a van der Waal interaction, hydrogen bonding interaction and all, which is maintaining that particular solid substances into specific crystalline form. And such theories are divided in amorphous, or it is not there in case of amorphous. That's why their arrangement is it's not like in specific shape as I showed you in earlier figure. Rather it is it is dispersed in environment, amorphous type of substances. So I am talking about the particular molecular arrangement which is there, and that's why it is known as amorphous, which is not in case of crystalline substances. So when we are specifically, we will see the examples of different crystals and amorphous solid. We can see cubic sodium chloride is appearing in the form of a cubic type of substances. So sodium chloride, which is cubic in nature, or a cubic form is there, or appearance will be there in cubic form. Rather urea crystals, if you will see urea substance, if you have handled, the actual crystals will be appeared in a tetragonal form. So four-sided crystals, or that the substance will be appeared in a four angle. So that's why it is a tetragonal type. So sodium chloride will not be having that tetragonal, rather cubic, in the sense three angles will be there in case of sodium chloride. And hexagonal, even urea may exhibit in hexagonal shape also, or hexagonal crystals also. Iodine, if you will see the rhombic, so elongated type of crystals you can see in case of rhombic iodine, which is known as a rhombic type of crystal. Then sucrose are monoclinic, the particular shape which is appeared in case of sucrose, that is a monoclinic. And boric acid crystals, if you will see, that is called as a triclinic. So this is what the thing about the different crystalline substances. So amorphous solids are a super cooled liquid with a random arrangement. So amorphous substance is not having specific crystals, rather these are known as super cooled liquids with a random arrangement. So that is what I said, you they will not be having any molecular shape size which is arranged in a specific direction, or it will be appeared in specific shape, appearance, or any specific geometry is not there. So that's why it is called a random arrangement of those molecules, which is known for amorphous type of solid. And amorphous and cubic crystals are isotropic. So the substances like amorphous and cubic crystals are isotropic in nature. So the thing which is specific about amorphous and cubic crystals are isotropic. They are isotropic in nature. Again, they have given some examples like ionic type of a bonding with available. We know this thing, Na plus Cl minus MgO single. Then molecular interaction like hydrogen bonding, dipole interaction, this London dispersion and all, which is appeared in case of H2 and CO2 gas. So this is the crystalline solid, which, or we can say this gas can be converted into crystalline solid in due to the specific bonding like hydrogen bonding, dipole interaction forces. Metallic type of forces or metallic bonding which is occurred in a specific metal ions like ferrous, magnesium, manganese and all can be used, or that the whenever they will interact with opposite or the correspondent ions, the actual bonding developed is a metallic type of bonding. Then covalent interaction, which if you will see, or covalent bonding, if you will see, it is in case of diamond crystals or even silicon dioxide, which is quartz. I don't know quartz you are knowing or not. If you have seen the what we can say UV cell, UV spectrophotometer जर cell जो आहे that is made up of quartz. So silicon dioxide is a substance by which that glass is prepared. I said you glass is a one substance prepared from silicon interaction. So silicon we are interacting with which substance, accordingly the glass will be appeared and glass will change its appearance. It will be transparent glass, or it is a non-transparent, it is a different color bearing glass. Of course we are adding some metal things and all, I mean metal ions and all, so that it will appear in yellow glass, in blue glass and all. So basically the glass is a form of silica, and pure form of silica interaction with oxygen is known as quartz. Okay, so pure glass, if you will see, that is quartz, and that's why we are using that UV spectrophotometer absorbance determination purpose, that is quartz cuvette or quartz cell we are using. So that cuvette is made up of from quartz, which is ultimately silicon dioxide substance, and these are also a type of crystals we can say. Finally, the amorphous material, if you will go in more detail, it is one kind of non-equilibrium material. I told you, not having any shape and all. Its characteristic of atomic arrangement is more like liquid and has no long range periodicity. So I'm not going more detail. You can elaborate those things in your examination point of view. Just you read it and you remember the basic thing: intermolecular forces, temperature, and even the proper geometrical shape, if it is there, in what manner it is there, any kind of a direction if it is going, that also you need to consider. Since it is amorphous, those things and all not there, or even we no need to consider those things. Okay, and but the what the actual pharmaceutical application and all that needed to be mentioned there. Glass forming ability of an alloy is closely related to its composition and is quite different in various alloys. Alloys in the sense some joint when they are making. Generally, amorphous alloy can be produced by rapid solidification method to freeze the liquid structure of alloy melt or other methods which may be used and that can mix atom to achieve disordered state. So they have given the example. See the amorphous substances, how it is getting formed. It is because of some alloys and all. And amorphous material have become one of the most actively researched fields. So every substances will not be in a crystalline or specific appearance. Rather, a number of substances, even tablet formulation, if you will think, you can see different substances, even calcium carbonate you are using, what we can say, silicon dioxide you are using. So these all things when you are using, that time you are able to see that those are not actual crystals, rather it is like amorphous substances. Even some binding agent and all, if we are using polishing agent for this during tablet formulation and all, these all are amorphous, not crystalline in nature, and these are mostly useful in research field. Even so many researches are going on these amorphous substances. The deep theoretical understanding and amorphization of non-equilibrium state guides and promotes research and development of amorphous material, because it's not having specific shape and all. So what is the chemical nature involved behind that, and what is the specific geometrical thing is associated? For that purpose, number of researches are going on in this direction. In this chapter, the atomic structure, formation criteria, preparation method, amorphous material, which we have summarized, and new progress in the formation of synthesis of bulk amorphous material and bulk amorphous based composition are introduced. So these all things we discussed up till now. So amorphous substances, though they are not crystalline and they are not any specific geometrical order or a specific direction, though they are having this much lacunas, they are very popular in pharmaceutical point of view, because routinely used substances are based on amorphous nature. So they are routinely used substances, and since they are not having size, shape and all, further studies are going on, or even research is going on those directions, so that amorphous substances, how we can utilize, or any future development can be done or not, in that direction research is going on. So finally, polymorphism, which is exist more than one crystalline form of chemical identical component, a difference in melting point. IR spectra is different for each and every polymorphic form, and the solubility in X direction. See, these all things are associated with the pre-formulation concept, because see, any substances if you are using for your formulation, in what manner it will affect your drug, or any compatibility is there or incompatibility is getting formed. Ultimately it is any like synergistic action of that specific drug will happen for its mechanism concern, a mechanism of action concern, and even any kind of an antagonistic action is happening or what, and finally it is contributing for loss of action of the drug or what, that also is considered. Example I will tell you, NaCl and KCl, both are salt only. Sodium chloride also salt, and potassium chloride also salt, and both are appeared in a polymorphic form, or what we can say in the crystalline form. But we should take a specific NaCl only. Why KCl not? Because there will be some kind of interaction will be there with the active pharmaceutical ingredient, or specifically drug, and that can be determined by melting point, IR spectra, solubility and X direction. Apart from that, substances may appear in a different polymorphic form, or different what we can say, isomeric form. Say like I given you example, cocoa butter. Cocoa butter will appear in three different form, like alpha, beta and gamma, but we are taking mostly the alpha and beta form, we are not taking gamma form. That also specifically beta form of cocoa butter is useful more. And this what we can say, Glucose in that specifically dextrose we are considered for pharmaceutical application, and even dextrose is having certain medicinal property also. Okay, so that's what is the medicinal property, in the sense that it will provide some nutritional or immediate nutrition purpose, like total parenteral nutrition. I don't know you people have heard or not this substance. If you will see any saline bottle or even uh, the glucose when they are giving to patient, it is written as a TPN, total parenteral nutrition. So because it is providing immediate energy to patient, or it is some nutritionally also it is important. That's why glucose in that specifically dextrose is given. So sucrose is present in a two different polymorphic form or isomeric form, that is a dextro and leo. In that dextro form is more active, and it is for a pharmaceutical interest also it is very important, because that is only having the more active nature, and it is providing some nutritional capacity compared to the leo form, and the leo form is not that much active. Even like that, so many drugs are there in pharmaceutical concern, adrenaline, non-adrenaline, which are exhibit is in specific isomeric form. So for even for in heart, in what we can say, antihypertensive treatment, they are using a different drug which are specific isomeric form only will be there. Even dopamine precursor is a dopa. So dopa also available in L dopa or do dopa. So in that L dopa only they are using. This is also the one thing, or isomeric form or polymorphic form, and because of that we are preferring based on its pharmaceutical value and activity. Okay, so whatever the drugs, noradrenaline is the one drug which is acting on heart, for constriction of heart and all, it is used. So these things and all, why we are discussing, because the isomer we are in specific concern about, because those isomer only or the specific isomer of substance only will be having the pharmaceutical application and specific what we can say, the action towards that particular disorder or that disease. Have you understood? So because of that only, that polymorphic form only we are considering. If you will see the coca butter also, if you will see the another polymorphic form compared to beta form, it is not forming the immediate melting nature or even immediate solid nature. Both nature we want. Have you understood? If you will see the coca butter, I don't know you people have prepared suppository and all or not in your first year. Forget it, this COVID issue and all. But in suppository, what we are doing, we are using coca butter substance, and active ingredient we are adding with that. So what we are doing, like a tablet, we are having a specific suppository punch molds. So what we are doing, we are pouring that liquid form of coca butter on that punch, and we are pressing and we are cooling it by applying some like wax and all. And after some time, after cooling, that coca butter with active ingredient, it will form solidified form, or that suppository or pastry will be getting form. But the thing is that if this is only the nature of beta form of coca butter, it will be immediately getting liquefied, and it will be getting immediately solidified form. So that is what we want. We don't want keep on a liquid form and it will not get a solid form, or we don't want actual solid form, it will never get melt, that kind of form also, which we don't want. So this is what the thing about polymorphic form of coca butter, glucose, non-adrenaline. I given you example. Depending on factors, I will give you in notes also, those examples are there if you will see. Here I am not going more detail and all. Depending on factors such as storage temperature, recrystallization solvent, rate of cooling, and rate of crystallization, the polymorphic form also may get changed. So interconversion of polymorphic form also may happen, or interchanging of polymorphic form. So alpha may get converted into beta due to excess temperature, rate of cooling excess. If you are, so there may be chance that polymorphic form may get converted into another one. Okay, so these are factors. If you will see that storage temperature, recrystallization of a solvent when we are doing cooling rate, how we are we are providing crystallization rate, how we are providing. So accordingly, the polymorphic form also may get change into another one. So alpha may get change into beta, beta may get change into gamma. Dextro form of glucose, which is a polymorphic form, we can say, compared to Leo. But what happening is, if you are providing heat, or it is, if it is affected with heat, dextro form will be getting deactivated, and again it will convert into Leo form. Have you understood? So dextrose will not be more active. That's why they are saying dextrose किंवा ते ग्लुकॉन डी वगैरे जे म्हणतो आपण, ते ग्लुकॉन डी ची साखर वगैरे आपण कूलिंग टेम्परेचरला स्टोर करायला पाहिजे. अदरवाइज इट शुड नॉट बी स्टेबल. तर अदर if it is getting converted into another polymorphic form, means it is remaining unstable or waste pharmaceutically activity, it will get vanish. Pharmaceutical activity will not be more in future. So we have discussed this up till now, the overall things associated of towards a state of matter and a different phase which is there exhibited by specific substances. So okay, so if I will see your syllabus, there is some physiochemical properties are there. Physiochemical properties also we need to study. I think afternoon one lecture is enough for me for finishing that physiochemical properties and state of matter and properties of matter. Just to try to remember a different state of matter, what are the actual condition by which it is getting converted into another one. Polymorphic form or polymorphism, I will ask specifically question in your examination, so be careful with that. Even once again, I will show you the syllabus, which is the thing remain. Okay. असू दे तिथंच राहू दे, तुम्ही जावा, ठेवून जावा तुम्ही. So this is the your syllabus, and up till now we have finished your first topic, and accordingly I have given you notes also. I hope you people are reading those notes. In second unit, if we'll see the second unit up to polymorphism, we have finished. Now it's upon you. Shall I start the physiochemical properties of drug molecules or not, for the second sessional examination purpose? Because this is the one thing which is there in second unit. If you are saying me to stop, I will stop here. If you are saying me, you can add this also for your second, I mean first sessional examination, I will add what you people are wishing. These physiochemical properties includes a refractive index, optical rotation, a dielectric constant, dipole moment, dissociation constant, and their determination means instrumentally how we can determine those things. Very easy actually. Refractive index कसे determine करायचं, optical rotation वगैरे. If you are telling me to stop, I will stop, and we will keep this up till now. Whatever happened, that only we will keep for your examination purpose. What you people are saying, me, you tell me, inform me, so that I will decide whether I should continue or not. तुम्हाला काय वाटतं, इथं थांबायचं आपण का ते ऍड करायचं फिजिओकेमिकल प्रॉपर्टी? Students, am I audible there?
Yes, sir, you are audible.
हा, मग तुमचं म्हणणं काय आहे, ते फिजिओकेमिकल प्रॉपर्टीज ऑफ ड्रग मॉलिक्युल्स ऍड करू दे का आतापर्यंत राहिलेला सिलेबसच इनफ आहे फर्स्ट सेशनला? What you people are thinking? तुम्ही डिसाइड करायचंय, तुम्ही सांगायला पाहिजे मला काय करायचं. कोणच आन्सर देत नाहीये. शॅल वी स्टॉप और शॅल आय कीप? जर तुम्ही म्हणत असाल सर ऍड करा म्हणलं तर मी दुपारी एक लेक्चर घेतो. वन लेक्चर इज इनफ फॉर मी टू ऍड दिस ऑल थिंग्स.
सर राहू द्यात ऍड करायचं.
नको म्हणताय का?
हा.
ऍड करू दे.
हा सर.
हा म्हणजे मग म्हणजे लेक्चर घेऊन संपवू म्हणताय का इथपर्यंत थांबवू म्हणताय?
ऍड करायला नको असं.
ओके ओके, म्हणजे अप टू पॉलिमॉर्फिझम आय विल स्टॉप. दॅट इज व्हॉट यू पीपल आर सेइंग.
हा या.
ओके ठीक आहे. मग मी फर्स्ट युनिट कम्प्लीट सोल्युबिलिटी ऑफ ड्रग कम्प्लिटली मी ठेवेन आणि युनिट 2 मधला अप टू पॉलिमॉर्फिझम आय विल कीप फॉर युअर फर्स्ट सेशनल. ओके, इज इट ओके फॉर यू पीपल?
Okay, sir.
आणि आणखी एक गोष्ट फॉर
ओके
एक्झामिनेशन
सर.
of view, I will be more specific on the partition coefficient. मी हा क्वेश्चन partition coefficient तुम्हाला विचारणार एक्झामिनेशन मध्ये आणि पॉलिमॉर्फिझम पण विचारणार, बिकॉज दीज आर व्हेरी क्रिटिकल थिंग्स for your future point of view. Apart from that, the routine things and all you people are knowing, most of things you are knowing, and solubility expression and all and their mechanism interaction towards drug and all that also I may ask. So solubility of drug, different factors, drug solubility, how it is affecting by different factors, that I will ask. Partition coefficient also I will ask, and polymorphism I will ask as a major question. So be prepared for those things, or ultimately you need to read those things. Remaining things you have to read only, that is different, it will come in multiple choice, but these will be the descriptive things. Okay, so I hope you people have understood up till now whatever we have learned. And I don't know, तुम्हाला काही टाइम टेबल सांगितले का मॅडमनी कधीपासून एक्झाम आहे वगैरे?
टाइम टेबल नाही सांगितलं, एक्झाम ऑफलाईन असं सांगितलं सेक्शनल.
नाही, एक्झाम तर ऑफलाईन असेलच, पण कधीपासून आहे किंवा काय डेट फिक्स आहे? कारण ते एक्झाम कन्सर्न मला माहित नाही काय चाललंय.
मॅडम म्हणलेलं 22 पासून म्हणजे स्टार्ट होईल, पण आता ऑफलाईन आहे म्हणलं.
ओके ठीक आहे, काय हरकत नाही. जर समजा 22 पासून जर ऑनलाईन एक्झाम असेल तर यू पीपल्स आर प्रिपेअर्ड ओनली, नो इश्यू. जर कुठला कन्सेप्ट समजला नाही किंवा एनी काइंड ऑफ प्रॉब्लेम यू आर हॅव्हिंग, यू कॅन शेअर. तसं काय कोणाला प्रॉब्लेम आहे का आतापर्यंत शिकवण्यामध्ये? वाय आय एम आस्किंग यू रिपीटेडली सेम थिंग, बिकॉज these things only will be there for your next pharmaceutic subject when you are entering in third year and final year. So they will depend on those things only. You will go and do formulation. Polymorphism मध्ये मी तुम्हाला म्हटलं की बाबा मी हेच फॉर्म बीटा फॉर्मच घेणार, then you should answer the question of that. What is the need of those that particular form only? Partition coefficient, I will ask you anything anytime during your SUTIX practical. Have you understood? Not only me, anybody else. What is the partition coefficient? You people need to give answer on that time. Okay, understood. So these are this physical pharmaceutic itself is having that much importance. So base thing you should not forget, and you should you should construct your basic and accordingly. Have you understood? So, okay, we will stop here only. Any kind of thing is there, as I told you, you can ask anytime or you can approach to your CC madam. And all the best for your second session. If it is there on 22, no issue. Suppose the session किंवा सेशनल एक्झाम एक्सटेंड होत असेल तर मग नेक्स्ट लेक्चरला मी फिजिओकेमिकल प्रॉपर्टीज ऑफ ड्रग मॉलिक्युल कम्प्लीट करेन. ओके, सो this is the my plan, and accordingly you people move. Okay, so we will stop our discussion here and we will disconnect. Okay, 1 second, I will just have your attendance.
तर 24 पासून एक्झाम.
24 पासून आहे का? शुअर आहे का? डेट तर करेक्ट आहे का ती?
टाइम टेबल आताच सेंड केलंय मॅडम मी. टाइम टेबल
24 पासून. पहिला एक्झाम कुठली आहे, म्हणजे पहिला पेपर कुठला आहे? पीपीस आहे का?
हा, एकच मिनिट
PO.
चेक करते.
पीपी सर 26 ला आहे.
पीपीस 26 ला आहे का? मग पहिला कोणता आहे?
ऑर्गॅनिक केमिस्ट्रीचा आहे.
ओके, नो इश्यू.
POC.
24
POC
पासून.
सेकंड.
ओके, नो इश्यू. 24 पासून आहे ना एक्झाम तुमची चालू?
हा,
मग ठीक आहे, फिजिओकेमिकल प्रॉपर्टीज कम्प्लीट करून टाकू. मग परत एकदा तुम्हाला जर ते सोयीस्कर असेल तर मी फिजिओकेमिकल प्रॉपर्टी ऍड करेन सेशनलला. जर तुम्ही म्हणत असाल नको सर ते ऍड करू नका म्हणता तर मी ऍड करणार नाही. पण फिजिओकेमिकल प्रॉपर्टी मी शिकवल्यानंतर मी त्यावर क्वेश्चन पक्का टाकणारच, कारण फिजिओकेमिकल प्रॉपर्टीज आर व्हेरी इम्पॉर्टंट फॉर युअर physical pharmacy, even for your annual point of view, annual examination point of view also those are very important. So I think I will ask you question, कारण पुढच्या सेशनला हे परत विचारत बसण्यात अर्थ नाही. त्यामुळे जर मी शिकवलं तुम्हाला, एक तर मी शिकवणार नाही, जर समजा शिकवलं तर तुम्हाला ते क्वेश्चन येणारच. ओके, 1 सेकंड. 4, 6, 7, 8, 9. Why roll number 4 and 9 are always remaining absent? I don't know what is happening with them. Okay, so आज अटेंडन्स बऱ्यापैकी आहे पण आय डोंट नो सम मेंबर्स वेर अब्सेंट सम स्टुडंट्स वेर अब्सेंट इन द अर्लियर क्लास सो प्लीज don't remain absent for your class and all because some concept which we can miss in notes but the concept when I am talking with you that will be very important. Even I will tell you so many examples so that may appear I mean that may ask like a question in your examination so that you can answer those things. So you are supposed to write down the examples and all because examples every time we will not give you or even in textbook and all very hard to find for you people. So please concentrate on lectures and all and don't remain absent. Anyway, we will disconnect our meeting here and we'll meet in next class if it is possible. Okay.